Okay, we're back and I'm doing another video for chapter 2 to finish it up. Last time we did up to completing the square, so this time I'm going to go over these sections, which are basically on solving um, quadratic equations and related topics and absolute value and inequalities. So let's start. I'm going to again turn off the video so we have more space to work with. So I'm going to start with quadratic formula and go from there. Now, so let's talk a little bit about quadratic formula. What is quadratic formula and how do we use it? Well, quadratic formula has to do with solving equations that look like this, which are quadratic, right? Now, if we can write it in this form and apply the completing the square to it, the previous section, we can end up with a formula that we can always use instead of applying completing the square all the time. So we have this very simple formula that we can always use to solve quadratic equations. Otherwise, we would have to solve it by factoring or by applying completing the square to each individual problem. Now, this way, if we apply the completing the square to this equation once, then we end up with a formula that we can always use. All right, now remember, this formula only works if your equation is in this form. If the equation is not in this form, let's say we have 2x squared minus x equals to 5. Now here, in this problem, 2 is a, negative 1 is b, but the c is not 5. In order for this to be c, you have to move it to the left. So if you write it as 2x squared minus x minus 5 equals to 0, now we have a is 2, b is negative 1, and c is negative 5. Okay, that's the only thing, really. So let's do a problem. It says solve this using quadratic formula. Now, to solve this, first we have to write this in the form that we had above. So we have to distribute this a. So a times 4a is 4a squared, plus a times 5 is 5a, and then minus 8 equals to 0, right? So, and notice that this a, you only multiply it by these two, not by 8, right? Because 8 is not inside the parentheses. So a here, our a, the coefficient is 4, our b is 5, and our c is 8, negative 8. So we just put them in the formula. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. So we just substitute b here and b here, and 4a has to be a, c, which is negative 8. So let's simplify inside the radical here. That would be 25, this minus and this minus right here make a plus. So that's plus 4 times 4 is 16. 16 times 8, or 8 times 4 is 32. 4 times 32 plus 4 times 32. That's one way you can do it. But another way you can do it, you can easily use a calculator to do the arithmetic so you don't make a mistake. So square root of, well, you could do it directly. 25 minus 4 times 4 times negative 8. There. Now, obviously this is not a round number, so let's just do inside the radical first. 25 minus 4 times 4 times negative 8, which is 153, right? Which is 153. So, and 128 plus 25, of course, if you did it by hand, would get 153. So that would be square root of 153, and we got to put an a also here too. So x is going to be negative 5 plus and minus the square root of 153 over 8. And then we take these together as a fraction, so x equals to negative 5 over 8 plus and minus square root of 153 divided by 8. So there are two numbers, and those are the two numbers. Now, if it's possible to simplify square root of 153, we could do that. So what is the square root of 153? Well, 153, is it divisible by 2? No. Is it divisible by 3? Yes, it's 51. And 51 is divisible by 3. What's times 51? It's 17, right? And 17 is a prime number, so this number is 9 times 17, right? So square root of 53 can be written as square root of 9 times 17, which is 3 square root of 17. So that can be written as 3 square root of 17. Now I believe even if you don't simplify it, you might get the correct answer. So if you don't simplify, let's see if you get the correct answer. So I'm just going to put 153 there instead. See if you get the correct answer. If not, that means you need to simplify. Yes. So we don't really have to simplify. You could just leave it as 153. Of course, the correct answer, when it's given, is in most simplified form. Okay? All right, so let's move on. Now, use discriminant to determine the number and type of solutions. Now, what is discriminant? Well, let's talk about that. So in the formula for quadratic equation, we have negative b plus and minus the square root of b squared minus 4ac over 2a. Now the stuff inside here, inside the radical, is called the discriminant. So b squared minus 4ac is the discriminant. Now, if it's 0, if the discriminant is 0, we end up with negative b plus and minus 0 over 2a, which is just negative b over 2a. So we just have one solution, right? One solution. Now, if the discriminant is a positive number, then we end up with the square root of a positive number. Now, if this positive number is a perfect square, like a square root of 36 or square root of 49, then what we have is just a rational number. A number comes out, let's say 7 or 6. So here we just have a number, and it will be negative b plus and minus some number over some other number. So it would be two rational solutions. If the discriminant is greater than 0 and is what? And is a perfect square. Perfect square. All right. Now, what happens if it is greater than 0 but it's not a perfect square? Let's say it's 39 instead of 36. Then the square root of 39 is an irrational number. So we end up with an irrational number here. And then if you add or divide by any number, if you have an irrational number, the result also will be irrational. So if this is greater than 0 but not a perfect square, then we're going to have two irrational numbers that are solutions. And if the discriminant is less than 0, that means it's negative. Now from previous section, you remember that if the inside the radical is a negative number, what happens? Well, then we end up with what? I times a number. And this I here is going to make the answers complex imaginary. So it's going to be two complex imaginary solutions. That means of the type A plus BI. So that's how we deal with that inside of the radical there, which is called discriminant. So here we are going to basically see what the discriminant is. So that's b squared minus 4ac. Now, let's substitute for those. The b here is 5, so that's b squared, minus 4a is 1, and c is negative 3. So that's a 25. This minus times this minus makes it a plus. And 4 times 1 times 3 is 12, so that's a 37. 37 is an irrational. If you put it under the radical, it would be an irrational number. It's not a perfect square. So you guess what the solution is supposed to be? Of course. It's going to be two irrational solutions. Distinct means they're not the same, right? All right. So that's all there is to it, to quadratic. These are similar problems. So I'm going to let you do the rest of them and go to the next section, which is solving higher order equations. Now here we know how to solve linear equations, right? So we know how to solve something like that. If you have ax plus b equals to 0, that's very easy to solve. Just isolate x. Move the b to the other side, divide by a. If you have ax squared plus bx plus c equals to 0, we know how to solve that. We can use quadratic formula. But if you have anything greater than 2, like something like this, let's say, we don't know how to solve it. So what we have to do, we have to try to make these, for now, convert them to something we can solve. That's the idea for this section. So let's look at this. Now obviously they don't have anything we can take out, all of them. They don't have anything in common. So that's out. But if we pair them, maybe they have something in common. So these two, the first two, have x squared in common. So why don't we factor it? If I factor x squared out of x to the third, what do I get? Well, I'm going to get is x to the third divided by x squared. I'm going to get x. That's x. And what do I get if I take x squared out of 8x squared? Well, I have to take 8x squared and divide it by x squared, which is 8. That would be plus 8. Okay, what do these two have in common? Looks like minus is 128 divisible by 16. Yes. What times 16 is 128? 8, okay. So 8 is what they have in common. 16 is what they have in common. It's 8 is when you divide 128 by 16. So minus 16. So what is minus 16x divided by minus 16? Well, it would be x. And what is minus 128 divided by minus 16? That would be plus 8. So these two now equals to 0. These two now have x plus 8 in common. So if you take x plus 8 out, and if you take x plus 8 out of this, you get x squared. If you take x plus 8 out of this, you get minus 16. So now we converted this equation that we couldn't solve to something that actually we can solve, because this equation is basically something times something equals to 0. Now, the only way this is possible is if we have x plus 8 equals to 0, or x squared minus 16 equals to 0. This one gives us negative 8, and this one is easy to solve. We can move the 16 to the side and use the square root method. Take square root of both sides. So x is going to be plus and minus 4. So we have 3 solutions here for this problem. All right. So, and there are 3 solutions. We can write them maybe from the smallest to, or in order, doesn't matter in what order you put them here. You just have to put comma between them. All right. So this is basically this section. It's about converting the equations we don't know how to solve into something we can solve. Again, the only trick here is so far factoring by grouping, right? So what do these two have in common? X squared. What do they have in common? Just a negative. So let's do this one too very quickly. And let me go from there. So here we can see, so what do they have in common? X squared. And if you take x squared out of x to the third, we get x. What do we get if you take x squared out of that? Well, you just divide to see it. You get 7, positive 7. Now these two have negative 1 in common. So what do you get if you take negative 1 out of negative x? We get x. And what do you get if you take negative 1 out of negative 7? You get plus 7. Now they have x plus 7 in common. So again, what did we do? Converted something we didn't know how to solve to something we can solve. Now we can set these equal to 0, or x squared minus 1 equals to 0. From here, x is negative 7, and from here x is plus and minus 1, because you have to move the 1 to the other side and use square root method. Okay, so I don't see anything in this section that you wouldn't be able to do. Let's look at a few more. If they're similar, we move on. So here is similar problem. So here, now remember we call this method that we just talked about, if you have something like that, call this a square root method. You take square root of both sides. But we don't do that for any other power. So we don't have something called cube root method. Doesn't work. We don't have fourth root method. It doesn't work, right? The reason it doesn't work is because these don't give us all the solutions that we want. So don't use that. That's why this is called the square root method. Okay, now, how do we solve this? Well, we can move everything to one side, like this, and then see what they have in common. Looks like we can have x to the fourth out of it, and then what's x to the sixth divided by x to the fourth? Well, that would be x to the second, because that would be 6 minus 4. And what is 36? 36x to the fourth divided by x to the fourth. Which is just minus 36. That's a minus 36. So again, something we couldn't solve. This is something we can solve, because we can write this as what? X to the fourth is like x to the second times x to the second equals, times x to the second minus 36 equal to 0. Now they're all quadratic, right? So that means x to the second equal to 0. Well, that's x to the second equal to 0 again, which gives the same answer. X to the second equals to 0, or x to the second minus 36 equals to 0. So here, from these two, we just get x is 0. If you take square root of both sides. Now from here, again, we can move the 36 to the other side and take the square root of both sides. We get plus and minus the square root of 36, which is 6. So we got 3 solutions, right? We got 0, and we got negative 6 and positive 6. So those are the solutions. Okay, it looks like we know how to do these problems. So what about solving equations quadratic in form? Let's see, what is that? All right, well, how do we solve this equation? Well, we know how to solve something like this. Let's say am squared plus bm plus c equals to 0. So change the variable to m because I use another variable here, x. So this actually looks like that. If we let x minus 6 be m, then we can write this as basically m squared plus 2m minus 8 equals to 0. So these kind of equations are quadratic in form. They're not directly quadratic, but if you change it just a little bit, make x minus 6 be m, then we have that. Now we can solve this. In fact, we don't even need quadratic formula for this because we can factor it. What are the two numbers? You multiply, you get negative 8, and you add, you get 2. Well, 4 and 2, and if you make this minus and make this plus, it works. So m equals to 4, or m equals to positive 2, m equals to negative 4, and positive 2, because you have to set these equal to 0, right? So m plus 4 equals to 0, then we get that. And then m minus 2 equals to 0, then we get that. All right, now, are we done? No. This says solve for x, not for, see, it's x, not m. But we know that m is what? X plus 6. So if x is negative 4, then what is m? Well, m is x minus 6, so m will be, so m, let me do this again. So if m is negative 4, what is x equal to? Well, we know that x minus 6 equals to m, and m is negative 4. So x is going to be negative 6 plus, negative 4 plus 6, which is 2. I mean, x is going to be negative 4 plus 6, which is 2. And then if m is positive 2, what is x? Well, x minus 6 equals to 2, so x is going to be 8. You just add 6 to both sides. Make sense? All right, so the two solutions are that one and this one right here. 2. So even though we couldn't do the problem directly, we can use, so 8 and 2. Those are the two solutions. All right. Now instead of m, you can use u or any other variable except for x. This one also, it's similar to the other one. Is it quadratic? No. This is to the 4th power. It's not quadratic, right? Can we make it quadratic? Yes. So all we have to do is, again, let m be what? Let m be that right there, x squared. Then this thing turns into x squared to the 2nd power plus 3x squared minus 4 equals to 0. We're going to write it like that. So that would be m squared plus 3m minus 4 equals to 0. Now, can we factor this? Yes. Find two numbers, you multiply, you get negative 4, you add, you get 3. Well, 4 and 1 plus 4 and minus 1. So either m minus 1 equals to 0 or m plus 4 equals to 0. So either m is 1 or m is negative 4. So if m is 1, then 1 equals to x squared. So x is going to be take square root of both sides, plus and minus 1. So that's good. That's two solutions. What if m is negative 4? If m is negative 4, that means negative 4 has to equal to x squared. If you take square root of both sides, we get plus and minus. Square root of negative 4 equals to x. But we know how to do with that. The negative comes out as I, and the square root of 4, of course, is 2. So x is 2i, and then plus and minus, right? So plus and minus 2i. Okay? So the solutions are basically these two and these two. Okay? And then you list them here, 1, negative 1, 2i, and negative 2i with commas. All right. this is similar to the one we just did. I'm just going to move on, let you do it. And this one also is similar. And all right, so very similar problems. Let's move on. So solving equations quadratic in form, we got that. Solving radical equations. How do we do that? All right, well, radical equations are equations that have, they're equations that look like there's a radical here, something is inside, and then equals to some number. This is the simplest one. So if that's the case, we could just square both sides and the radical goes away. So for example, if you have radical, x minus 1 equals to 2, just square both sides. This side squaring makes that go away. And then this side we get 4, so x equals to 5. Now, if you have two radicals on both sides, like something like this, different thing here, then you can still use the same method, just square both sides, and you just continue this way and can solve it. But if you have two radicals, and then on the other side is not 0, is some number, then this would be something that we have to do a little bit more work, because if you square both sides, this side is, you can't get rid of the two radicals at the same time. Because if you square this side and you square this side, you're not going to be able to say something minus something is squared is just something is squared minus something is squared. That's not true. That's a common mistake. So we're going to look at this and we do one of these. But let's just start with the simple ones, and then we'll go to more complicated ones. So this one, we have a radical, so we can actually square both sides. So we're going to take square this side, square it, this side we square it. On the left, when we square it, just 3x minus 2 comes out. On the right, we get x squared. So the trick with radical equations is to convert them to something we can solve. And remember what we can solve: linear and quadratic, right? That's all we can do. Linear and quadratic. Ax squared plus bx plus c. Those are the kind of structures we can deal with. So the point is to turn this into something we can solve, and we just did. Now that we can solve because this is quadratic. So let's move everything to the right-hand side and make the left side 0. So here we go. X squared minus 3x plus 2, right? You move these to other side, you have to change the sign. And this is the same as if I put the 0 on the right, right? That's the same thing. So that's x squared minus 3x plus 2 equals to 0. And this is something we don't really need quadratic formula for, because we can solve this easily. Multiply two numbers to get positive 2, add to get negative 3. Well, negative 1, negative 2. And so the two solutions are x equals to 1 and x equals to 2. Now we have to check and see if it works. So let's see if this works. Let me erase this and see if this works. Well, if I put a 1 here, I get the square root of 3 times 1 is 3 minus 2 is 1, and the square root of 1, yes. If I put a 2 there, I get the square root of 3 times 2 is 6 minus 2 is 4, and then on the right hand side I also get 2, square root of 4 is 2, so it does work. So the solutions are 1 and 2. 1 comma 2. All right. Now, well, this one is similar, so I'm just going to let you do it. See if you can see something that is a little different from what we just did. Yeah, this one is a little different because it has what? It has 2 radicals. Now, first of all, before I do this, we have to make sure we know that a plus b squared is a squared. Did you say plus b squared? I hope not. I hope you didn't. I hope you didn't make all mathematicians turn in their graves. No, it's not. And if it is a minus b squared, that would be a squared minus 2ab plus b squared, right? All right. So, so we're going to work, first of all, understand that. So that means you cannot just say, okay, I'm going to square this side and square this side, then square this side. Excuse me. Then this side, this just becomes that square, the square root goes away, and the square root goes away, and we're done. No, that's not how it works. It's not going to work. If you square both sides the way they are, then notice that you're going to get this situation here. You're going to get the first square root gets rid of, you can get rid of. The second you can get rid of, but in the middle you're going to have 2 of them. So that doesn't work. So let's not do that. So instead, what do we do? Instead, we're going to move one of these to the other side and write one of them as equals to 2 minus square root of x minus 1. And now, after we do this, we can square both sides. This side would be just negative x plus 5. Now that side, remember, is going to be this squared, which is 4, minus 2 times that one, and then times that one. And then plus that one is squared, which is x minus 1. Right? So now we have only 1 radical. So that's good, because we had 2, now we have 1. So let's do all the operations on both sides. So we got a 4 here and a minus 1 here, so that's a 3. And then we got an x there, we're going to leave it. And then this is minus 4 square root of x minus 1. Now, we're going to move everything. We're going to move this square root, known as for a square root, to the left and move all of these to the right. We were trying to isolate the square root. So what I have is 4 square root of x minus 1 equals to 3 plus x, which is there already. This minus x goes there, becomes plus x, and this 5 becomes minus 5. So we end up with 4 square root of x minus 1, and 3 minus 5 is minus 2, and x plus x is 2x. Okay, now we can square both sides again. Now we can square both sides. Square this side and square this side. Now squaring this side, 4 squared is 16, and the square root of x minus 1 squared is x minus 1. Equals to, again, we have one of those expressions, something plus something is squared, is negative 2 squared plus 2 times negative 2 times 2x, right? These are one thing, and this is another thing. So plus 2 times that one plus 2x squared. So this would be 16x minus 16 equals to 4. Now, minus 2 times 2 times 2 is 8. Plus 2x squared is 4x squared. All right, now this is something we can solve because it's quadratic. So we're going to move everything to the right-hand side and make this side 0. So I'm going to write them in, doesn't matter in what order, I'm just going to write them for now. And then I'm going to move the 16 to this side, becomes minus 16x, and then plus 16. All right, now we got the 4 and a 16, that gives you 20. Then we got 4x squared and 16x minus and 8x minus, that's minus 24x. And then remember we had plus 20. So we got all of those equal to 0. Okay, now, can we divide everything by 4 to get rid of this 4 here? Yes, we divide both sides by 4. Now 0 divided by 4 is 0. 4x squared divided by 4 is x squared. Negative 24x divided by 4 is minus 6x. And 20 divided by 4 is 5. Now, so let's write it over here. X squared minus 6x plus 5 equals to 0. All right, can we solve that? Yes, we could just factor it, right? We can say this is just x what? This is x plus 5 and x minus 5 and x minus 1. Let me change that. So it would be x minus 1 and x minus 5. Right? If you multiply, you get positive 5, you add, you get negative 6. So the two solutions are x equals to 5 from here and x equals to 1 from there. Okay? So x equals to 1 and x equals to 5. Now, let's go back to the original one and see if they work, because they may not work. If x equals to 1 here, that would be square root of negative 1 plus 5, so square root of 4. Square root of 4 is 2, right? Let me move up a little bit. So that would be just 2 plus, if I put a 1 in here, that would be 0. Equals to 2, yes. That's good. Okay, what about 5? If I put 5 there, that would be 0. And then plus 5 minus 1 is 4, so that's 2 equals to 2. Yes, that works too. So we found these two solutions that actually work. Okay, so the goal was to turn that into something we can solve. So those are the solutions, 1 and 5. All right, so that's all there is to it. That was probably the hardest one. It's similar here. You can do that. Just again, don't try to raise both sides to the second power if you have two radicals on one side. Move one of them to the other side. This is very easy because you could just move the 3 to this side and square both sides, and I did one of these for you already. All right, so that's the radical equation. What about other types of equations? Well, let's see what types. All right, what about something like this? Well, we can take out what they have in common out. So let me show you the work here so I can explain it. So what we have here is between these two exponents, 13 over 4 and 4, they have 13 over 4 in common. So we could take 13 over 4 out of it. So how do we take 13 out of 4 out of it? Well, we factor it out. So let me write it here so I can do it. So if we take now 7 and 189, is 189 divisible by 7? Yes. So 189 divisible by 7, we get 27. So it is. So we get 7. Let me get a whiteboard so we can work on it. So I got 7x to 13. So I have 7x to 13 over 4. I want to factor that out, right? Now to do that, well, what do I get if I divide 7x to the 4th divided by 7x to the 13 over 4? Now remember, 7 and 7 go away, so that would be x to the power of 4 minus 13 over 4. So this is the exponent of x here. So what would that be? Well, that would be x to, what is 4 with the denominator of 4? Well, that would be 16 over 4 minus 13 over 4, which is what? Which is 3 over 4. That would be 3 over 4, right? So that would be x to 3 over 4. And then what is minus? So let me erase this so we can do the second part. So what is to that? So what is a negative 189 x to 13 over 4 divided by 7x to 13 over 4? Now 189 divided by 7, negative 189 divided by 7, as we saw, was negative 27, and these get canceled because they have the same power. So we see that we have two expressions now, either this equals to 0 or this equals to 0. And we can set them equal to 0, either this equals to 0, which basically, if you divide both sides by 7, you get x to 13 over 4 equals to 0. And to get rid of the denominator, you can raise both sides to set to a 4th power. Because, you know, the powers work like this. If you have x to a and then to b, the answer is x to ab. So now, here one of the powers is fraction. So what do I raise it to get rid of this denominator? That means 13 over 4 times what gets rid of the denominator? Well, that would be 4. So I need to raise both sides to the 4th power. I take this side and I take this side and raise them to the 4th power. Now on the left, the 4 goes away, so we get x to 13th power, and 0 to 4th is 0. Now x to 13th power, since this is 0, we could just take 13th root of both sides. How do you take 13th root of both sides? Since this is 0, we can do this. So we take 13th root. The index would be of x to 13, equals to 0, this would be x equals to 0. So x is 0. Now, the other equation is when this equals to 0, right? So I'm going to write as x to 3/4 minus 27 equals to 0. Well, that would be x to 3/4 equals to 27. Now, to first get rid of this 4, again, we have to raise both sides to so we're going to raise both sides to 4th power just like we did before. So if you take this and raise it to 4th power, well, we get x to the 3rd equals to 27 to the 4th power, right? All right, so now what is the real solution for that? Well, we can take what? We can take now 27 to the 4th power is a number, so that would be 3rd root of that number. So you're looking for, so the 3rd root of that equals to the 3rd root of 27 to the 4th power. So x is going to be, now later we're going to see that how to find the complex solutions, but for now, let's, where did my mouse go? Here we go. So what we want to know is what is the 3rd root of 27? Well, 3rd root of 27 is really 27 to the 4/3 power. That's what that is. Now, what is 27 to the 4/3 power? Well, we can use a calculator. 27 to the power of 4/3. That's 81, right? So basically, if you raise 27 to the 4th power is a big number and take root of it, it's going to be 81. Okay, so so those are the solutions. So x equal to 0, and then x equals to 81. That's what that is. All right. So that's when we have fractional powers. So you can actually factor the smallest exponent they have in common, right? So if you have something like this, if you have something like x to the 4th plus x to the 3rd equals to some number, let's say 0. So what do? We take the smallest they have in common, right? Now, if this was a 3/2, we could also take the 3/2 out. So we would take something like this, and then we'll divide x to the 4th by x to 3/2. That would be 4 minus 3/2, and it goes here. What is 4 minus 3/2? Well, 4 is 8/2, minus 3/2 is 5/2, right? So that would be 5/2, and then plus what? Plus 1, because these two. So that's the idea in the previous problem. You have the smallest exponent and you factor it out. So of course this problem is not like that. This problem has only one x is x to 4/3 power. So first, x to 4/3 power equals to 16. So first thing, we get rid of this 3. We raise it to third. We raise both sides to 3. So that would be x to the 4th equals to 16 to the 3rd power. That's what we're going to get. Now, x to the fourth. Why do we get x to the fourth? Because you have to multiply these powers. So it's x to 4 over 3 times 3. And the 3's go away, so we get x to the fourth. And now here we take fourth root of both sides, and we get the answer. So fourth root of that would be the fourth root of 16 to the third power. Again, we have a formula with exponents that says a to m over n is nth root of a to m. We can go from left to right or from right to left. So this thing, if you want to use a calculator, would be 16 to the power of 3 over 4, like that. Sometimes these numbers are nice and sometimes they're irrational. Do you think this number is nice? Well, we'll see. There's 16 to the power of, don't forget parentheses, 3 over 4. And it looks like it is. It's 8. So this is just 8. Now, here's the problem. If you take even root of both sides, right, then you would have to put plus and minus. Because what we do here, we have to take, remember, even root. And when you take even root, so if you take nth root of x to n, this is plus and minus x if n is even. And if you take nth root of x to n and n is odd, then this is just x, not plus and minus. In this case, we have to put plus and minus. So the answer has to be plus and minus. Now, it says assume x is a positive number, so that means I didn't see this, now I see it. So the answer actually could be a negative as well, but since they say x, assume it to be positive, then we can just forget about the negative answer. Just write the positive one. All right. If we were not told that, then the answer would be both. In fact, I could give you, tell you something about this section. We can't, as remember I told you not to use what? Let me explain this. I said if we have something like this, don't take fourth root of both sides. Move this to this side and you have to factor. But if we assume x is a positive number, we can do that, because we lose all the complex solutions. But for this section, it's okay. You don't have to worry about it. So you can take, in this section only, you can take 4 for fifth root of both sides. All right, so let's see. What else? Is similar to what we just did. So you're going to take which one of these fractions is the smaller? 1/3 is the smaller. So you can take 1/3 out of this. So if you take the 1/3 out, then you end up with, let me show you. So you see, if you take the x to the 1/3 out, and the original one was, let me write it here. I want to get both of these. Let me just do this one too. So you see, if I take 9x to 1/3, factor that out. Now, what is 9x to 1/2 divided by 9x to 1/3? Well, the 9 goes away, and this would be x to 1/2 minus 1/3, was 1/2 minus 1/3. But we have to make the denominators the same. So that would be x to what? 3 over 6 minus 2 over 6. And 3 over 6 minus 2 over 6 is 1 over 6, and so we get x to 1 over 6. And what is negative 18? X to 1/3 divided by 9, x to 1/3. Well, negative 18 divided by 9 is negative 2, and these two cancel. So that's how we get this right here. And then again, you do the same thing. You set them equal to 0. The rest of this is, let me show you. The rest of it, you just set them equal to 0. If you set that equal to 0, you just get 0. If you set this equal to 0, then you would get this equals to 2 and raise both sides to 6 power to get this answer. All right? All right, so rational equations we solved before. So remember rational equations, we had 3 denominators. So let me just show you what the common denominators should be to multiply by, and let you do the rest of it. So we got x minus 6 here, x minus 6, and x minus 5, and this one. So the denominators of x minus 6, x minus 5, and this right here is actually x minus 6 times x minus 5, because negative 6 times negative 5 is positive 30, and then add them, you get 11, negative. So basically, how many different factors do we have? Only 2. So LCD here would be just what? Would be just x minus 6 times x minus 5. And then if you multiply that by these right here, so if you multiply this one by that, then the denominator goes away. You're going to get negative x minus 2 times what? Times x minus 5. Right? That's what that becomes if you multiply it by this right here. And then this one, see what that is a plus? Yeah. So that one, x minus 5 goes away. So we get x minus 6. So it would be plus 4 times x minus 6 equals to, now since this is the same as this denominator, this whole denominator gets cancelled, so we just get negative 4. So if you simplify this, you end up with a quadratic, and you can solve it and get the answer for this. Remember, if any answer makes the denominator 0, like if you get 6 or 5, then you should not accept it as an answer, because you can't have the denominator be 0. All right, so I'm just going to move on. I can show you the work here, which we simplified. If you simplify, you see that's what we get. And then if you multiply all that and simplify, you end up with a quadratic. Again, either with quadratic formula or factoring, you solve it, and you get your answers, and check them and make sure they work. Now, notice that in this case, we end up with one solution which makes the denominator 0. So we have to exclude that. We're not going to consider that to be a solution. So the only solution is 2. That makes sense. The other one makes the denominator 0. All right. So again, this is a rational equation similar to the one we just did. You factor them and turn them into an equation, and as you see here, let me show you again. If you factor this, it would be x plus 1 times x minus 6, and Again, it simplifies it into that, converts into quadratic, like that, and then you solve it. You don't have to factor it. If it has a 2 here or doesn't have a 1, it's easier to just use quadratic formula and get the 2 solutions. Then check, right? Now notice here, in the original problem, -1 cannot be a solution and 6 cannot be a solution. So it looks like we got 1 and -15/2, which are not the 2 that make the denominator 0. So they're both good. All right, so what about this one? Well, here is -1/2. So the way we deal with this is we can think of it as, let me go back. So we can bring it to the denominator and make it a +1/2. That's just square root, right? That would be a square root. So if I think of it as, let me show you that. So we can raise both sides to the power of -2, cancels the exponent on the left, and then we get that, right? So we can make the exponent 1 by raising it to -2. That's one way to do it. Or you could also make this go in the denominator. Then would be +1/2. And now you take reciprocal of both sides. That means x minus 4 to 1/2 equals to 7. And now raise both sides to second power. It will be 49. So x equals to 53, right? So instead of raising to -2, you can make the power positive first, and then take reciprocal of both sides here. You get this, and then raise both sides to second power. X minus 4 comes out, right? Because x minus 4 to 1/2, and then to second power, you multiply these two, you get x minus 4 to the first power. So that's how it comes out. All right, so the answer to this is 53. It's similar problem here. You make it positive first, and then so you can make it 1 over x to 3/2 equals to 125, or if you you can take the reciprocal, so x to 3/2 equals to 1 over 125, and now you raise to second power, you're going to end up with, if I raise this to second power and raise this to second power, I get x to the third equals to 1 to the second is 1, and 125 to the second power. And now I can take cube root of both sides, so x equals to cube root of 1 over 125 to the second, in parentheses. Now what is that with the calculator? Well, first of all, what is 1 divided by 125 to the second power? Is that, and then we have to take cube root of it, which means raise it to 1 over 3, something like this. So it's 0.04. So 0.04 is 1 over 25, right? So that's that's a way to do these. Now, I didn't use fractional. If you can use fractional power, if you take something, so for example here, if you take something and raise it to 3/2, you have to be careful that since the denominator is 2, you're taking second root. So that means the right-hand side has to be plus and minus. Now, plus and minus whatever it is. Now, if you have something and you raise it to the fraction 2/3, then you're actually taking cube root, so you don't have to put plus and minus on the right-hand side. If you're careful with that, then you can just take raise to fractional powers instead of getting rid of denominator first. So in this case, in this problem, the way I did it, it would be, you could also do it this way. You say, I'm going to raise both sides to negative 2/3. 125 to negative 2/3. Now this would be just x. Why? Because when I raise to this, the denominator is 3, so that means is a cube root, so I don't have to worry about plus and minus. So that would be just 125 to the power of negative 2/3. And calculator can do this for me. She's going to give me again 0.04. 0.04, I mean. So 125 to the power of negative 2/3, like that, which is the same as 0.4, and you can convert it here, math, convert to fraction, get 1/25, if the answer has to be in terms of a fraction. All right, so let's move on to interval notation and inequalities. What is that? I think this is just a review of interval notation. So it says solve the following inequality. Well, solutions to inequalities has to be given in interval notation. So this inequality is, let's work on it quickly and then put it in the enter it. So this inequality is a linear inequality because x is to the first power. So to solve linear inequalities, we just move all the x's to one side. We get negative 8x plus 7x is less than or equal to negative 9 minus 1. So what did I do? I moved this negative 7x to this side, and I moved this 1 to the other side. And I changed the sign, of course. So I moved this negative 7x to this side. So negative 8x plus 7x is negative x. Negative 9 minus 1 is negative 10. Now we're not done because we have to divide by negative 1 to get rid of that negative. And with the inequalities, if you divide both sides by a negative number or multiply by a negative number, you have to switch the inequality. Now I could give you an example. For example, 2 is less than 3. But if you divide both sides by negative, you get that, which is not true. You have to change the direction. Because on the number line, negative 3 is here and negative 2 is here. So negative 2 is actually bigger. Bigger, I mean to the right of negative 3. So that's the only catch, that makes sure that if you divide or multiply by a negative number with inequalities, you have to switch the direction. So here we write x and 10, then we have to switch the direction. So this means what? This means x has to be greater than or equal to 10. That means all the numbers to the right of what? To the right of 10, including what? Including 10. So let's do that. So that means we have to, let's see, move, how do we move that? Here we go. To move that to 10, and then move that to infinity, like that. And we don't want empty, we want it to fill in. Because it's empty, that means 10 is not included. So we want to make sure 10 is included. Something like that. And that is correct. So what about this one? Well, again, we have to divide both sides by negative 10. So x would be, I have to change the direction. It would be x greater than 8, negative 8, because you divide by negative 10. Okay, what about this one? You have to divide by negative 3, and we get x greater than 4. You have to change the direction. So it says, use the number line to express the following. The set of all numbers less than or equal to 0 or greater than 6. Set of all numbers less than or equal to 0 and greater than 6. So it has to be less than or equal to 0 or greater than 6. How do we do that? Well, less than or equal to 0 means what? Means that it has to be to the infinity. This has to be less than or equal to 0, which has to be here. Let me move this that way. So less than or equal to 0 means that, right? So set all numbers less than or equal to 0. Or greater than 6. So we don't want it to be 6, we just want to be greater than 6. So you have to move this to 6, make sure this is empty, and then move this to infinity, like that. So you see, that's including 0 to the left, this not including 6, and to the right of 6. That's how we set it up. All right. So here is another inequality. If we have an inequality like this, where we have, when we have actually two inequalities here, then we have to convert it into two inequalities. So basically what we have here is a compound inequality. So this means this and this, right? So that means we have negative 5x minus 7 is less than negative 3x plus 9, and then that one, negative 3x plus 9 has to be what? Less than or equal to negative 5x plus 5, right? All right, now we have to solve these separately and then see what they have in common. So if you move the 3x to the left side, we get negative 5x plus 3x less than, and then move the negative 7 to the right. That would be 9 plus 7, which means negative 2x is less than 16. Now you divide by negative 2, you get x is negative 8, and you have to move this greater than, because we divided by what? By negative 2 on both sides. So that's one answer, x greater than negative 8. So let's put it here. So here is negative 8. We don't want negative 8, but we want everything to the right of it, right? Okay, what about the second equation, second inequality? Let's do it over here. So move the 5x to the left, so we get negative 3x plus 5x is less than or equal to, 5 is already there. We're going to bring the 9 to this side and make it a minus 9. So negative 3x plus 5x, that's 2x, less than or equal to negative 4. Divide by 2, don't change the direction because we didn't divide by a negative number, we divided by a positive number. So that's the second solution. But the second solution is what? That x is less than or equal to negative 2. Now negative 2 is about right here somewhere, and we do want negative 2, and we want everything to the left of it. Now the question is, what do these have in common? Well, think about it. They have this part in common, right? Now, so negative 8 is included here, but is not included here. But remember, we want a number that is in both, because it says and. So that's a negative 8 is not included. So it would be all numbers between negative 8. So let's put it here. So we don't want negative 8. And then all the numbers all the way to negative 2. Now negative 2 is here and is here. So negative 2 is good. That's negative 2. So we want all the numbers from negative 2 to negative 8. But we don't want negative 8, we want negative 2. That would be the solution for this inequality. Right? So all the numbers from negative 8 to negative 2, but so all the numbers from negative 8, we don't want negative 8, and then to negative 2, was it negative 2? Yeah, negative 8 to negative 2. So negative 2, and we do want negative 2, right? Yes. So negative 8 we don't want, and negative 2 we want, and all the numbers in between. So that is the solution for that one. All right, this is similar, so I'm gonna let you do it. Similar problem. So these are all inequalities that, again, we got 2 of them, just similar to the one I did. So it's a set of all numbers greater than or equal to 5 and less than or equal to 7. It says use interval notation to express it. So if you want to do this, then you can put it on a number line. So we want all the numbers greater than or equal to 5, so it's 5. Greater than or equal to 5 means all of that. And less than or equal to 7. And less than or equal to 7. So let's put and 7 is here. So we want 7, and we want everything to the left of it. What do these have in common? Looks like it's that, right? So it's all the numbers between what? Between 5 and 7, including 7 and 5. And with interval notation, we just put bracket, right? 5, 7. All right, so I'm gonna end this video here. And so we did up to interval notation inequalities. So I'm gonna do another video, and I'm gonna do these last 3 sections for chapter 2. Okay. So until next time, I see you, and take care. Eat lots of vegetables and fruits. Okay. All right. See you next video.